minutes. Should be a pretty quick one today, so I'll try and go fast. Okay. Today, we've been talking about functions and what they are. We talked about the vertical line test. Today, we have to start talking about some things we know and some things that we're going to learn about in the future. Okay. We know about linear functions. Okay. They are the functions. They are y equals mx plus b, right? So we did for months this year, right? We did y is equal to mx plus b nonstop, right? All we're doing right now is expanding on that. We're saying y is equal to mx plus b. Well, we're not going to call it that, right? We're going to call it f of x equals mx plus b. Now, in order for something to be linear, it doesn't necessarily have to be this mx plus b form. We saw other different forms, right? We saw ax plus by is equal to c, right? That was another form we saw of things that were linear, right? But we don't really do this because in functions, like you could have this, you know, b times f of x is equal to c. No, I mean, your f of x typically in a function is by itself, because this right here is not I plug in x, I get out f of x, right? If you see this, this is I plug in x, I plug in y, and I get out c. So we're not so much going to see this form as a function. We'll talk about how you can and how you'd rearrange it, but really we're focused on things where f of x is isolated, where it's by itself, okay? So a lot of these, okay? But it could be in a different order. It doesn't necessarily have to be in this order. What if I said g of x, some other function, g of x is equal to b plus mx? Is that okay? Sure, right? All we do is change the order a little bit. But here's the thing. In order for something to be linear, we say it is closed under addition, subtraction, multiplication, and division, okay? In other words, you can only have the four basic operations. And if you think about that, if we go to our basic form here, right? Y is equal to mx plus b, right? What is this really? Let's think about this. M times x, right? We have m times x. M times x, this is just a multiplication thing, right? M times x. Or what if m was a fraction? What if I said 1/4 times x? Well, that's 1 times x divided by 4. So that's just really x over 4. That's really could just be multiplication, or if we put a fraction, it becomes division, right? And if we think of this plus b, well, it's obviously could be addition, but what if we were adding, what if I had a 4x plus a negative 2? Well, adding a negative, you guys know, is the same thing as subtracting. So this is something that's been pretty innate in us for a while, right? Is that we're going to multiply something and then we're going to add something, right? Or we're going to divide something and subtract something. Some combination of these four things. So if those are the four things you're allowed to do, what are you not allowed to do, okay? So they will make some different shapes here. So first of all, I just want to show you that what happens when you have something that is in addition, subtraction, multiplication, division is what you guys should know already, is that when you graph it, it will make some sort of straight line, right? That will make some sort of straight line. That the slope will be constant. We'll talk about how you're going to find that from a table tomorrow. Today I just want to tell you guys what are some other things that you can do that would make it not linear, and how could you tell that, okay? So there's a couple we're going to focus on, okay? And I'll show you what their graphs look like, okay? What if I said f of x is equal to 1/2 x to the second power plus 2x plus 1. This right here makes it nonlinear, right? We said we have addition, subtraction, multiplication, and division. We didn't say anything about exponents, right? And that will be the first type of one we talk about when we talk about nonlinear functions, okay? So if you see any type of exponent, whether it's second power, third power, fourth power, fifth power, it doesn't matter, automatically no longer linear, right? What if we said, what are some other things we know? What about square roots, right? You guys know how to do square roots. We did that earlier this year, right? Is that addition, subtraction, multiplication, division? No, that's a different operation. That's a square root. So these are nonlinear. Okay. Let's talk about a couple other ones you guys might see. This. Now, division's a little bit tricky. We are allowed to have x divided by 5, but we are not allowed to have 5 divided by x, okay? This is what we call a rational function, and we actually don't cover those until you guys get into the 11th grade, okay? So if you see an x in the denominator, that's no good. So I just want to show you guys what these 4 graphs look like, and I'll show one more would be, I'll show you guys a cube root, okay? So some of these we're going to look at next year in algebra, some we're going to look at immediately this year, and some of them we don't look at for quite a while. So just to show you guys, if I go to Desmos, some of the other functions. So we know how to do linear, right? So linear is one of like 11 functions you guys have to know. So what if I said y is equal to, I'm sorry, f of x is equal to x squared, right? Well, we get a nonlinear function, right? This is not growing. This is not a straight line. This is not, this is not a straight line. This red one, right? So what if so some other ones? So that has 2 as an exponent. What if I had 3 as an exponent? Right? Even odder looking, right? Kind of squiggles up there. And we'll talk about those, and you can explore. If you guys go to Desmos, you could just type in x to the 4th, x to the 5th. I don't even think you have to put, I think if you just put x to the 4th, it'll show you what it looks like, yes. Again, what else did we look at? We looked at square root graphs, right? The square root of x. We get this odd one, right? What if we did, oh, we got all sorts of, you see, why I press the functions button, look at all these. Let's go. Cube root kind of looks like that weird squiggle. You'll see some of those. What was the other one I showed you guys? Oh, and how about that one? There you go. There's your 1 divided by x graph. Okay. So we get these kind of crazy, weird, different types of functions, but they're definitely not linear. They definitely don't. That's not a straight line, right? That's a messed up, right? And again, as we go further and further into high school, there's going to be, we've got sine graphs, we've got we got a bunch that we're going to have to graph over the next couple of years. So I try and emphasize how important this topic is to you guys, and that's why we kind of take it slow. But we're going to have a lot of different functions that we have to do over the next few years. So pretty much all you got to do today is go online and tell from what they gave you on IXL whether things are linear or nonlinear, okay? Now from a graph, it's pretty easy. If it's a straight line, it's linear, okay? If it's dots in a straight line, it's linear. If it's anything else, it's nonlinear. From an equation standpoint, all you're looking for is, hey, does it have something that's not addition, subtraction, multiplication, division? Does it have an exponent? Does it have a square root? Does it have an x to the denominator? Does it have a cube root? Anything that's not addition, subtraction, multiplication, or division, that is going to be nonlinear, okay? So guys, have at it, give it a try, and I'll talk to you tomorrow.